ZombieTech. Welcome to ZombieTech, a forum for engineers, scientists, and inventors to ponder on the technologies needed to survive the inevitable zombie apocalypse.
She's Addie.
He's Whisker.
And this week we're talking to...
Jeremy Blum.
Jeremy
Hey guys.
Blum.
I imagine many people who listen to this podcast also subscribe to Jeremy. I have watched all of his wonderful tutorials and have seen him pop up at various conventions and summits and radio shows and whatnot because Jeremy is an overachiever whose single goal in life is to make the rest of us look like we're lazy.
Oh, come on now. I just make the rounds.
So, I don't even know where to start. Projects. I mean, you have done so many freaking projects. We've got the Arduino tutorials, or tutorials for Arduino.
Of course.
We have the pseudo glove. There's the MakerBot. You worked for MakerBot this summer.
I still work for MakerBot.
You still work for me. Fantastic.
Yeah.
And what else am I missing? I mean,
I don't know. I mean, there's a lot of stuff thrown in there,
he does,
I guess.
a lot of stuff with school when he's there, too, working on their efficiency with how they use their energy, etc.
Yeah, I do a lot of sustainability work. I lead a big sustainable design project team here. So that's, I mean, I would say that consumes 90% of my waking time at school, probably. It's a huge time commitment.
So what all have you guys been doing? What's the projects? Where's everything going with that?
We do quite a bit. This past summer, I was at MakerBot, but our team, one of the projects we ran was called Schoolhouse South Africa. We sent 30 students to South Africa, and they built a passive schoolhouse. One of the projects that I'm leading right now aims to build a new research facility on Cornell's campus, which is where I go to school.
Mm-hmm.
So that'll be a new building on campus that will research interdisciplinary sustainability, allow professors and students and grad students to come together and work together on problems that they wouldn't ordinarily get to work together on, and help solve energy issues. And, while I would agree it's very likely that a zombie apocalypse will certainly end the world, I think it's also equally as likely that an environmental catastrophe onset by humans also has pretty great potential to destroy the world.
Sure.
So
Sure.
that's what we're trying to help avoid in whatever way we can.
Now this building that you guys are creating, is this also a green building?
Yeah, it's very multi-purpose. So the building itself is designed to be sustainable and kind of net zero energy footprint.
Wow.
We're going through the design process now. But more importantly than that, the building itself kind of is the research, not just the development of it, but it's supposed to be like a living lab for energy research. So suppose, for example, we're going to have a modular walling system, and someone in the material science department develops this new installation that has a higher R value. And they want to test it in a real life building. You swap out one of the walls with a wall made of their material and use a sensor array in the building to isolate variables and see how it performs.
Now, are you guys going to be having like code issues? Is the city hall going to come and be like, "Excuse me, guys"?
Yeah, I mean, there's a lot of bureaucracy that goes into this, and it's for that reason it's a pretty long-term project. We started work on it a year and a half ago now, and it won't be complete for a few more years, but we're making excellent progress on it. We have a lot of support from the administration, and it's a lot of fun. It's a great project, and I mean, it's especially good because it gets students who are on the team the opportunity to do some like serious hands-on work that you don't necessarily get from your classes. And the team used to be this team called Solar Decathlon, which some listeners might be familiar with, which is this competition. 20 universities from around the world build these solar powerhouses, bring them to the National Mall in DC, and present them, and you compete in a bunch of competitions to determine energy efficiency. It's actually, the 2001 competition is going on right now, this week. Or next week. It starts in a few days, I think. And the last one we did, the 2009 competition, I designed the control system for the building. And it was such an awesome learning experience when we were like, well, we can do better on our own. So we started this group. And it's great. It gives students a pretty awesome learning opportunity.
Now, how exactly do you control a solar-powered house with a power glove?
So, well, let's see, the student glove was developed after the completion of that. But thinking on it now, it would be kind of cool to go back and set that up. I'm always thinking of new implementations for that thing.
Yeah, I saw the concert, the music performance stuff. That was pretty.
Yeah, that was fun. It was very out of my element because I'm so not musical at all.
It's like, is that Jeremy doing an interpretive dance?
Yeah, that was an interesting one.
That's cool.
I took that class last semester, that music class last semester. I thought it would make me go out of my comfort zone a little bit, which it did. But if being me, I obviously found a way to use a bunch of my other stuff in it. So it ended up working out pretty well.
That's cool, though.
You got that thing sitting there. Why not use it? It's
exactly.
Cool little piece of technology.
Yeah, it's fun.
So then, when you're designing, you're an double E, right?
Yeah. Well, now it's technically ECE, Electrical and Computer Engineering.
Oh, okay.
Yeah, a lot of schools renamed it to that.
Gotcha. So when you're designing an interface for like that solar powered house or what have you, how much detail do you have to go into in terms of conserving all the possible energy you can from your connections? I mean, like, do you go down to the component level? Do you?
I mean, to the greatest extent possible. There's, I would say there's more complexity involved in doing these things than any one person can ever possibly handle.
Mm-hmm.
It was a team of people. It was far more. There were 150 people on that team, and I led the electrical controls team.
Right.
But there were a tremendous amount of other people contributing. But for example, for the controls, we had a centralized media computer that allowed you to kind of on a TV screen control all the lighting in the house, the air conditioning and the heating, and monitor energy usage, all that stuff. And like with that computer, we didn't just buy a computer. We built a computer trying to pick out all the components that would be as energy efficient as possible, solid state drives and all that.
Mm-hmm.
All that stuff, and doing the energy analysis, and then the biggest part of it, part of saving energy is knowing where your energy is going. Knowledge is just the biggest part by far.
Sure.
Because once you know, it's easier for you to take action to save energy, or for the house to take action for you, which is what we did. And so we had this smart load panel that was developed by this company in Israel that we worked with pretty closely. And it monitors all the circuits in the house, tells you exactly how much they're using at any given time. It can load balance based on the time of day and how much electricity costs and how much solar power you're currently generating, and balance all these variables. But most importantly is that it spits out all this information, and you can see exactly where your energy is going, when you're using the most, when you're wasting energy. And just knowing makes a huge difference.
Oh, absolutely. You can just use that data to develop technologies for a long, long time, actually.
Yeah, absolutely. The data is exceptionally useful.
Cool. Very cool.
You'd be surprised looking at the difference between people who have access to like literal information about how much they're using when, and people who don't. Just knowing that information is enough to change how people behave on a day-to-day basis. It really is.
Oh yeah, it's massive. Especially when you relate it to the amount of money you're spending on energy.
Oh my God, no kidding.
Yeah, when you can tell someone, you have your hair dryer on for 5 minutes in the morning, and that costs you exactly $1.37 of energy. That's pretty relevant information.
A lot more air drying.
Yeah, seriously.
This is a topic that really comes up in the context of this show, basically every single show. The efficiency of being able to use energy in a situation where it's not necessarily infinite or plentiful.
Right.
Because zombies take over, there's no more nuclear power plants, there's no more refineries, there's no more oil tankers. You may be able to scrounge up some petroleum to burn in your generator for a while, but that's going to go away pretty quickly.
Yeah, no, I think definitely first thing you do zombie apocalypse is find a source of energy. I'd head to my nearest GE headquarters or whatever, and scoop up 10 kilowatt array worth of solar panels.
and move south to where it's nice and sunny all the
Yeah,
time.
I'd have to get out of Ithaca because it rains here like 90% of the time.
We actually have one of our zombie teams strapping his solar panels to his back. So
Oh, nice.
we've got some of those coming our way.
Yes, everyone that comes on this show basically adds a little bit of intelligence to the design of how we should actually approach rebuilding society. Because in our group, it's not enough to be able to survive the zombie apocalypse. You got to be able to survive and rebuild.
Yep.
Yeah.
Yep.
So you guys should build. You guys should assemble like a book of all this information. gather together everyone's ideas and make the ultimate zombie apocalypse survival guide.
Zombie apocalypse cookbook.
That's a great idea. And after after a year of this, I imagine some 50 different engineers from different fields, we will probably have more than enough information to really
That'd
give
be
a go
awesome,
of it.
Actually, that's a very good idea.
Yeah.
That's a very good idea.
I would buy it. I would buy that book.
Why, thank you.
Most definitely.
So, I guess another thing also is the MakerBot. I mean,
Yes.
you've done a lot, it seems, with that, and I got to watch your nice 3.5-minute video on assembling the MakerBot, and that, I mean, that's a lot.
I like the parts where he ate lunch and then ate dinner. And...
I wish that was lunch. That was actually dinner and breakfast.
Oh my god!
One followed by the other. So that was I was putting the bot together during my last week at MakerBot,
Wow.
and it was a Tuesday night, and I was leaving on my last day was Friday, and I was basically going back up to school on like Saturday or Sunday, and I knew I couldn't wait to build it at school because once I got to school I would have no time. So I was like, okay, I have to build it before I leave.
Right.
And plus I had all the tools in the workshop there at my disposal, which was convenient. But I couldn't do it Wednesday because there was like some event at night, and then Thursday my parents were going to be in town, and then Friday I needed to like leave. So on Tuesday I was like, oh crap! I mean, this is my last chance. So I started building it at 8:00 at night after work, and then I finished the next morning at 8 a.m.
Wow. There you go. 12 hours, folks. 12 hours.
Yeah.
No,
It was,
I know a lot of people are sort of, if they have access to other machines, they're doing like fabricating custom mods to it. Did you just build it stock?
I mean, I put a bunch of extra lights in it. I made a few modifications to the carriage and, things like that, and rearranged the electronics from the default configuration. But, I mean, it's more or less stock. There's nothing crazy going on in mine. There will be eventually once I get time to actually do it.
But I mean,
but I mean, it works great. This thing. I've been printing for the last. I actually I was down for a week or two because I needed a new Z-axis motor. But I got one when I was in the city for an Open Hardware Summit and Maker Fair last weekend. And I'm printing stuff. I printed recently, or last night actually. I like the helping hands for soldering.
Sure.
So I have those, and they come on like this metal stand, but I lost the actual thing that the metal stand goes into. So I designed a new one and printed it, and I have a new stand.
All right.
It's
That's
like
amazing.
super. I mean, it's like so simple, but it's just like really convenient. Because otherwise, this thing is that thing's useless to me. There's no way to make it stand up.
Right.
We're doing a bit of that kind of stuff here this week. You were sleeping when the video went live, so I'm sure you haven't seen today's video. But
I'll check it out afterwards.
we're beginning work on a jib for our new studio.
Oh,
and
cool.
It's going to be all motorized. So, you're talking about having to go pick up a new Z-axis motor. We're doing a motorized jib that has a gimbal on the end of it that can do pan, tilt, zoom, follow focus, jib right, jib left, and fly it up and down too.
That's cool.
So,
What's
it's going to be fun.
What's the control scheme you have in mind?
Now Jeremy's getting ideas on how he would do it. I can see the gears turning.
I'm thinking.
We're using a prop, because we're a propeller household here.
Right.
No offense to anyone in this conversation who may use other platforms.
No, I love the propeller. I've used it in several projects. I have actually this past week in Open Hardware Summit, one of the giveaways was the new propeller development platform.
Yeah.
I haven't gotten the opportunity to play with it much yet, but it looks pretty cool. I went over to the Parallax tent too at Maker Fair. They've got some cool stuff going on. I love the propeller.
Was that the tattoo on your left arm?
No, the tattoo on my arm was the open hard. It said "Open Forever" and it was the Open Hardware logo. So I got the. That was one of the things in like the goodie bag at the Open Hardware Summit.
We'll get to the Open Hardware Summit and Maker Fair here in a bit, but to answer your question, we're using a prop, and basically what I'm planning on doing is just doing H bridges and pulse width modulation to ramp up and ramp down the speeds, and running all the motors simultaneously, but doing an nth dimensional plot through multi-dimensional space. So like I can get them all to be moving at different speeds so that they'll all arrive at the right place for the next mark simultaneously, right?
Right.
So it'll swing the boom and it'll fly it down and it'll zoom and it'll tilt and it'll pan all at different speeds, and when it gets to where it's supposed to be, they'll all glide to a nice little stop. Yeah. So that
sounds really nice.
It should be really smooth. It should look like a human is operating it. And I just want it to be simple enough so that we can have a couple of buttons sitting on the set desk, and you punch position 1, it goes. You punch position 2, it flies over there. And you don't even have to think about it.
Just so I can use it without breaking it.
That sounds really awesome. The one, obviously, being in college is great, but the one issue with it is I move like every 7 months.
Yep.
So I can never set up anything permanent, and that's kind of annoying.
Well, you got to have a to-go kit.
Oh, I do. I mean, I've got my zombie apocalypse essentials. I've got my soldering iron. I have about 8 boxes of electronics.
That's awesome.
My
I
MakerBot.
can hear Jeremy looking around his room right now.
Yeah, you can probably hear my voice moving around from the mic, right? I'm trying to like look around and see all the stuff I have. Multimeters. Oh, Dremel's key.
Yep, you gotta have a Dremel.
Gotta have that. Toolkit, hammers, etc.
I think he's prepared.
Oh, I'm prepared. I don't mess around.
So let's see. Over last week was a whole bunch of stuff going on over in your neck of the woods. We had the Open Hardware Summit and Maker Fair, both over the same weekend, basically. And I know that's like right by where you were. And last week we had Adam on here, and I believe you ran into him while you were there.
Adam.
AJ Fabio or Violet Kisso. Yep.
I ran into him.
And another friend of ours, Robot Girl, Erin.
Yep, I ran into her too.
And of course the folks from Parallax, who we all know and love.
And them, yep. It was Open Hardware Summit Maker Fair was like the best weekend ever. It was just great. I mean, I'm still catching up on work, but I just don't care because it was so awesome. And oh man, so much free swag from the Open Hardware Summit. I had some great stuff.
There was some impressive stuff.
Yeah, I put off of my Flickr set, I put individual photos of every single free piece of free whatever that I got. They were both great events. The speakers at the Open Hardware Summit were phenomenal. It was just inspiring and very great listening. It's hard to keep me glued to my seat. I get bored easily with things that last more than like 5 minutes. So but I was glued. I couldn't move. The talks were great.
We got to see a bunch of them on the stream.
Yeah.
Yeah, you might have seen the back of my head in the audience.
And you were Element 14's tweet person too, right?
Yeah, I was tweeting the crap out of that conference. I sent out so many tweets. Oh my god, it was like 150 or something.
Thanks for doing that. We all appreciated it because those of us who couldn't attend, it was nice to watch the stream, but it was really nice to have like 4 people that we knew who were right there on the floor watching.
Yeah. No, I'm happy to do it. It was a lot of fun.
Cool. Now, what did the general vibe feel like was it like was there a certain future that everybody's kind of going towards, or certain excitement about a certain project?
There were a few interesting things. One of the things I thought was interesting is kind of like, so right now when you think open source hardware, you think pretty much releasing the schematics and the Gerbers and all that stuff for PCBs, right?
Right.
I mean, that's basically that level of design. But one thing, I mean, there were a lot of things they were talking about. One thing that was talked about that was interesting was kind of expanding that outwards in both directions. So going down to the IC level and going up to the whole system and design process level and opening those things up too. Especially interesting with IC, opening IC design. That's just not something that happens now. You can't get the fab files for, how they etch the different layers in an IC.
Right.
I think that would be very interesting. Frankly, I have no idea what I would do with it because I don't have access to a chip fab. But I mean, it would still be really cool to be able to get that level of detail. And when people are working on complex boards and stuff, to be able to see exactly what the IC is doing, is potentially very useful at a logic level. And then the other way, there were talks about Amanda Wozniak gave a great talk about kind of opening up the whole design process and making sure that you share everything and all the kind of thought processes that go into that. And on the interesting converse of that, what's his name? Nathan, the CEO of SparkFun, gave an interesting talk about not opening, from a business perspective, only opening the things you need to. So he's like, we open a lot, we tell people our designs, we tell people all our profits for the year, but we don't tell people the salaries of the people who work here. We don't tell everyone everything about the company. You don't have to. You can open selectively. Right. He made a good point, which is open the things that people care about. A lot of companies are getting really on this bandwagon and getting a little overexcited and opening everything. And frankly, we don't care about everything. Open the things that are important for people to use your work meaningfully. Some things don't matter. Right. And then another great one is open source ecology, which is not so much focused on the electrical stuff, but more on like mechanical open sourcing, which I think is equally as relevant. And I frankly, I don't think it's covered well enough in the open hardware definition right now, like mechanical hardware as opposed to just electrical hardware. And it's tough to necessarily give it the same definition because it's just a very different sort of platform, but it's still really relevant to what a lot of people are doing. So that was very interesting too.
Cool.
This one interesting bit of news from today that I think relates to this idea that a lot of people are to that point where they're like, okay, this closed system is no longer functioning. It's stopping innovation. Earlier today, I guess it'd be yesterday now, we stayed up all night so that we could do this with Jeremy this morning. But yesterday, awesome. Someone started a petition on whitehouse.gov with a goal of getting 5,000 signatures on this petition by this time next month. So 4 weeks to try to get 5,000 signatures. They got 5,000 signatures within a couple of hours. The petition is to stop the U.S. Patent Office from issuing patents for software from here on out.
Interesting.
Yep.
Within a couple of hours, 5,000 signatures.
Yep.
Wow. So anytime the Patent Office comes up in general, I don't even know like what argument to make because it's just so messed up and the whole system is so completely screwy. I don't even ever know what to say about the Patent Office because I just don't understand the way it functions. I don't think anyone completely understands it. And
I think I've got a pretty good idea, and I think the purpose that it's serving at this point is not the purpose that it was designed to serve.
Yeah, that's the impression that I tend to get.
My general way of explaining it to people at this point in the game is that the patent office is a munitions factory, and there is a Cold War going on between the mega corporations, and they're all building up these nuclear arsenals of patents.
Yeah.
And if anybody pulls the trigger, they can't, because if they do, everything's going to go to hell. Apple can't say to HTC, don't do this because HTC is buying up patents just as fast as Apple is, and Microsoft has even more, and blah, blah, blah. They're basically putting themselves into a cold war of patents.
That's a really good analogy.
The patent office is basically the munitions factory. They're the ones who are mining the uranium, if you will.
Yeah, no, that's interesting. I mean, and with the the recent bid from Google to buy Motorola, and I mean, it's very clear the only purpose of that was to grab up Motorola's patents so that Apple and Microsoft would get off their back, and I'm sure it'll work. Yeah, it's a huge mess. It's completely defeated the initial purpose of it, which was to help foster innovation by allowing people to have a great idea and then profit from it. And that's all just meaningless now because all the patents are owned by these gigantic mega corporations and like especially in the electronics field and obviously in the software field since it got all those petitions, there's like nothing left to patent. I mean, it's in software, if you do anything, it's related to something that's been patented somehow. Because there's only so many different ways that you can approach a problem, and obviously I'll be proven wrong on that because obviously new ideas come up. But realistically, it's people avoid innovating now because they don't want to get sued for patent problems.
Right.
And to some extent, there's the real problems have so many patents around them that it is no longer profitable to try to solve those problems. It is more profitable to try to solve problems that you invent, which is why so much of the marketing is focused on saying that everything is going to go mobile. It's like, can I, produce my podcast mobile? Can I do my graphics design? Can I do my video editing? Yeah, I could do so in a very hackish, back-asswards way. I don't want to do it that way. I want to sit down at a proper freaking computer with a keyboard and a mouse and a monitor that can do real work. I don't want all this crap to go mobile. But there's not as much money in focusing in that market because it's been patented into the ground. There's just no room for profit.
No, I definitely agree. I have this gigantic ass desktop that I lug up to school every year that I have my setup here and I can sit down and I can do my work in front of an actual computer. And I have a laptop too, but I don't use it to do anything super serious. And and then the same thing goes with my phone. I have the Droid 3 now, which is a great phone. But every time I take a video on it and it's like, do you want to upload this to YouTube? I'm like, no, I don't want to freaking upload a video to YouTube that I took on my cell phone. No one wants to see that. I just never got that.
Yeah, and there's, of course, different levels of users with different needs. I mean, a lot of people, they just want their freaking phone that does whatever. But for folks like us who are like into engineering and actually producing professional level content, we need real machines. And for us to be able to get that cheaply, we need to be subsidized by all these other people buying the equipment so that it can stay at our level, so that you don't need to be a gigantic megacorp to be able to own the means of production to do this new media stuff. And I know you're into like the open hardware thing, but you're also into this new media stuff. I can tell because of you got your YouTube channel up with all of these tutorials, and you work with Element 14 on all that stuff. Yep.
And as much as I would love to use open source software and open source hardware to produce all my videos, that is unfortunately not yet feasible. And when it becomes feasible, I'm more than happy to attempt it. But for now, it's not a reality, which is unfortunate.
Yeah, it's still in a position where you need to buy proprietary stuff from the cameras all the way through to the editing software. And if some of you open source hardware people want to get together and work on camera technology, we're all for it, man.
Yeah. I'll add it to my to-do list. Make digital SLR.
Now, there was an interesting conversation that popped up around something that I think it was your boss that was talking about publish your crap.
Yeah, that was great.
Share or die.
Yep. Share or die.
Some people started having a conversation. It was sort of spread around Twitter and IRC and all over the place. You know how it is. That the basic idea started to come together that wouldn't it be interesting if someone cooked up a foundation somewhat like the EFF.
Mm-hmm.
And the idea of it was to build up a organization that could establish things into the public domain to protect them from being patented. So if you had an idea and you didn't want to own it because you knew you weren't going to do something with it,
Right.
this group of people who, has all these lawyers doing their pro bono work and whatever, patent attorneys, etc.,
Mm-hmm.
you could hand it to them and they would go through the legal stuff. If they thought it deserved to be protected, they would just go through that process and protect it and put it out into the public domain in such a way.
Isn't that what listing your stuff in the public domain does now?
Well, from what we've been hearing around, that there a lot of
Recent
the
weeks,
lobbies
actually.
are trying to push some stuff through and are succeeding to try to change it so that prior art no longer applies. It's no longer prior art, it's first to file.
Oh, interesting.
Yeah,
I
I
mean, so
don't
we can be corrected too.
I
and
don't know
would
all the
rather
details
be,
on
but-
this, but that's what I've been
yeah.
hearing.
Yeah,
That's interesting. I'm pretty sure that as of right now, though, still, if
it's still prior art.
yeah, I mean, if you slap public domain on something you do and you write like, I hereby release this work into the public domain, like that's it. No, other people can't snatch it up and use it for can't copyright your work.
Mm-hmm.
I mean, that's I think that's sufficiently
Adequate.
adequate for releasing something into the public domain.
Yeah, and that's how it's always been. So when I hear things like this, it sounds like something that these superpowers, these patent superpowers would want, and something that they have the lobby clout to be able to try to get. So
Right.
just hearing about it makes me nervous, even if they're not doing it. It's like, gosh, don't give them that idea.
Hearing about anything that goes on in Washington now makes me nervous. There's just no end. There's just no end to it.
Pretty much.
There is one, and it involves zombies. But the downside to that is you end up getting chased around, and you gotta have really thick concrete walls and check your water for infection. It's no good.
Yeah, it's a bummer.
So with this open source hardware and software, how is it being pushed in education? Is it significant in the education
Not
atmosphere?
not as much as I'd like to yet, but it's getting there, and it's making headway. That's something I feel very strongly about, which is using open source hardware and software and technologies along those lines for education.
Mm-hmm.
Because I think in general, especially in the United States, engineering education is lacking at best, and it's pretty bad. So I've always thought this is a great way to get stuff in, and I give two perfect examples right off the bat. MakerBot
Yep.
does gives educational discounts, and they try really hard to get stuff into the classroom. They when I was there over the summer, I helped do a teacher workshop where a bunch of teachers came in and learned how to use the MakerBot and 3D design tools so that they could work with them with their students, which is a lot of fun. And there's they've done more since I've been there, and so that's great. And then at Cornell, Cornell has this thing called Fab at Home, which is another 3D printer. Slightly different objectives in the MakerBot. I actually work on it, and they have this program called Fab at School, and they do a lot of really awesome work getting open source hardware, 3D printers that they design into schools, and easy tools for kids to work with them. They've done a lot of studies recently working with kids who are underperforming in math, let's say, and putting them in a room with all this stuff, and they just they latch right onto it, and they start asking these questions about science and math, and it gets them really interested and excited about what the possibilities are, because it becomes tangible.
Mm-hmm.
And I think 3D printers is one way to go in that direction, but pretty much any open source hardware software is relevant for that. And there's stuff like coming out of the Media Lab, and there's the Arduino. The Arduino is a big one for that educational stuff. They have that new. This was talked about at Maker Faire, their new robotic system platform for the Arduino, which I'm sure will have impacts in that regard. And I don't know. I think that's gonna open source hardware and software is what's gonna end up making the biggest splash in terms of education. And preparing the next generation for a potential zombie apocalypse.
So is that where the future of 3D printing is going, towards changing education? Maybe.
I think it's branching in a lot of directions. I think one of the most important ones is definitely into the realm of education.
Okay.
There's a lot of other things where it's obviously very useful for, but I think getting kids access to something that lets them really build something right in front of their eyes is super significant for getting them into these kinds of things.
Sure.
Now, how viable is the MakerBot type of technology, the 3D printing? Say if you wanted to start up a small business around, manufacturing small parts. I mean, is it there?
I mean, you would need to have a farm of them. If you wanted to start up a company printing parts on demand for people, you could do it, but you'd be running your bot constantly. I mean, these things are not super fast yet. You can tweak them and get them to spit something out pretty quickly, but for complicated parts, I mean, it can take 2 or 3 hours to print something out. And if you're not going to be able to run a sustainable business, printing, fulfilling one order every 3 hours, right? And then especially because sometimes you might not use the ideal settings and it might not come out great, and then you have to do it again, and then you waste a bunch of plastic. And
right.
I don't know. I don't think using the MakerBot or the Fab at Home or like personal level 3D printers, that technology is there yet. But companies like 3D Systems, where you can like order stuff on demand from them, or no, not 3D Systems. They make printers. It's the name is escaping me. But I mean, there are companies where you can order away, but they use commercial level printers like Stratasys and stuff to print these things out, and they have a whole bunch of them and things like that.
Yeah, I come from the industrial arts background of doing, from the school of doing like injection molding and casting and that sort of stuff.
Right.
I would imagine that that's still probably the most cost-effective way to mass produce things.
Yes.
But these MakerBots, these 3D printers, they seem to be like they might be an easier way to do one-offs.
Oh, absolutely. They're great for prototyping. And I mean, like at MakerBot, we use MakerBots to prototype parts for the MakerBot.
And that's where I think the technology like really sort of shines. I mean, if you're doing your own R&D, one of these things is just great.
Yeah, no, totally. I mean, it's great for that, and that's a lot of where they go into the industrial design realm. People who will eventually be injection molding stuff, but first want to see how it's going to look before they pay several $1,000s for the tooling and the casting for an injection molded part. You print one out, make sure everything fits right, and then go to the next step.
Brilliant.
Now, how are they working on other materials besides just these easily used plastics?
I mean, they already have, right? So right now you can buy from them 3 types of plastic. It's ABS plastic, which is the standard, PLA, which is like corn-based, it's biodegradable, and PVA, which is water-soluble. And since we released the new dual extrusion system at Maker Faire, it's now theoretically possible to use, this is still experimental, but you can do it using the PVA water-soluble stuff as support material for an object, and then dunking in a bath of water, it dissolves, and then you have your object with those hollow voids wherever you needed them. Cool. Which is pretty cool. But I mean, there's always going to be new materials coming down the line. I'm sure they're researching new stuff, right? But I don't know about all of it.
There's an author, you might be familiar with him, Neil Stevenson, and he does some cyberpunk stuff. Well, he did during that era. One of his books, The Diamond Age, is basically all about nanotech and extruding products. Yeah. Now, in a 3D printer, you're basically building up layer after layer, moving, from the base upwards. In the case of extruding from raw atoms, you're pushing the part out from a surface that is able to, feed each layer one after another, and it comes out forward. Do you think that is like possible at some point?
I don't think it's impossible. There was some interesting technology that was being researched by Intel and Carnegie Mellon a few years ago that was along those lines. I don't know how far it's progressed since the last time I saw it, but that's kind of what they were going for. And I've done research in my lab at school on a project called Programmable Matter. That's kind of like that, but it's not nearly at the atomic scale yet, not even close. But it's at like the millimeter scale, where you have kind of individual components that are smart little parts of an end product that assemble themselves together into some object.
What kind of objects?
Whatever you design. I mean, nothing exceedingly complex because the technology is not there yet. But like, suppose.
Like, what's the end goal then? I guess.
So I think the end goal is self-assembling robots. You kind of just like dump a bunch of this material into a vat. You type into the computer what you need, or let's say you're stranded in the middle of an abandoned hospital and there's a zombie attack outside, and you need a wrench to lock the door closed before they come in and eat your brains.
Right. Right.
You say I need a wrench, and you program it into the computer, and then you pour these nanoparticles or whatever you want into the vat, and they assemble themselves into a wrench, and you have a wrench, and you can lock the door closed.
And then
like,
can you disassemble them?
A crescent wrench and
yes.
Earl Grey hot. Yeah. I like it.
That's brilliant. That's brilliant.
I mean, that technology is decades off, if I had to guess. But there's a lot of DARPA grants around that kind of stuff, self-assembling robotics. DARPA is very into that kind of thing.
Mm-hmm.
And
I mean,
that's
DARPA,
the sort of thing that you get into the gray ooze. It's like, is that really a good idea?
Yeah, right. And then we have to start worrying about the robot apocalypse in addition to the zombie apocalypse, or the combination robot zombie apocalypse.
Oh boy, robot zombie love.
See, we had Clark with his 2001 and the subsequent stories that came after it. At one point, the monoliths started to go self-replicating in the atmosphere of Jupiter, and they started turning the raw elements in Jupiter into more monoliths that would, in turn eat more of Jupiter and turn themselves into monoliths. And it eventually basically turned into a black hole and then went supernova, and there was a new star there. It's like, that's like self-replicating robots gone completely, to the brink. And that was something that he wrote, probably 40 years ago now.
Right.
So the idea has been out there for ages.
Yeah.
That's very interesting. Now, there is another project that you've been working on in, I guess, your Cornell lab. So one of them is the programmable robots. Another one, I can't remember the name, but it's like
machine metabolism.
Yeah, what's that all about?
That I'm not working on it heavily anymore. I'm waiting for a research paper to go through on it, but it's essentially, in a nutshell, like okay, let's see, how do we describe this? Okay, so imagine, the reason why we call it machine metabolism is, imagine the human body, how proteins and enzymes work.
Yep.
Right? So you have this protein structure, and the enzyme latches onto it and reconfigures the protein in some way to perform some kind of purpose. And the idea behind it was similar. So basically, it's this robot. You put it on a truss structure, which is meant to emulate a protein. Mm-hmm. For the truss structure, you can imagine like cell phone tower. One of the things I'd like to see is like International Space Station. And so you imagine this truss structure, you put this robot onto it, and the robot is able to navigate around this truss structure, grab onto parts of it, remove them from the structure while it's attached to it, and then reattach them in a different part of the structure, such that without any external influence or anything, this robot is able to reconfigure these raw materials or this part that was one thing into a completely different thing. So one example is, you need to put up a cell phone tower. Right now, people climb up this thing and people die, putting these things together. Right. Instead, you put a bunch of girders on the ground. You stick the first four girders in the ground. You put a gigantic robot on it. It picks up the other ones and then climbs up and assembles it as it goes. And that's kind of, that was the end goal of what I was trying to accomplish. And there's further research being done in that kind of subject area. But I basically got that going on a scale the robot was like about a foot wide, and then trusses that were like a foot and a half wide. It would move around and detach them and all that stuff.
Cool. Very cool.
Yeah, that was a lot of fun. That was a great project.
Yeah.
Imagine what you could do with that kind of thing. Think back to the 20s when they were sort of replacing the superstructure in New York City with steel, right?
Right, yeah.
And all those guys had to go up there and rivet all of those skeletons for those buildings.
Yeah.
Imagine just, thousands of these robots, climbing up and, doing the same thing, but wow, that's just
right.
that's a crazy image in my head there. I like it.
That would be really cool. Someday, maybe.
Someday.
We'll see.
So then now, I mean, obviously you've just started your senior year, right?
Yeah. Yep.
You just started your senior year. You're working on a bajillion projects, like with the sustainability group at your university, Cornell. What other projects have you committed to?
Oh man. So let's see. So the lab where I did machine metabolism and programmable matter, I've kind of been doing like a different thing in there every year to mix it up. So this year I'm working with the Fab at Home team, helping them with their electronics, which for their 3D printer, which has been interesting because we collaborate with MakerBot, but I can't share everything back and forth. So that's kind of a internal struggle sometimes, but obviously I've cleared everything with both sides.
Right.
So I'm doing that. Let's see, what else? I don't know. I'm trying to look around my room and figure out what I'm doing. I'm just trying to have a good time. I'm doing, this is still up in the air because the organization is a little bit messed up for it, but they're doing a TEDx talk at Cornell next week, hopefully. So I'm gonna talk at that, but I have to actually still make my presentation. It's gonna be about open source. And yeah, I mean, I'm working on MakerBot electronics remotely here, so that's taken up a good chunk of time. I'm like putting together grad school applications, which is also a fair chunk of time. Occasionally I have to actually do problem sets, which is unfortunate, but also, that's a chunk of time. And
just 3D print an apple for your professor.
Sometimes it's almost painful paying attention to what Jeremy's up to, because he's the sort of person who should be in the workforce, but he's the sort of person who should be in school. And these things aren't always compatible.
Yeah, it's difficult to manage both.
Because it's like you're gonna get a doctorate. I mean, it's just obvious that you're gonna go all the way with that, but it's also obvious that there's like 4 or 5 companies that would just love to snap you up right now.
Mm-hmm.
I'm not sure about the doctorate. I'm still kind of going back, and I definitely want to at least get a master's. I'm going back and forth between getting a master's and a doctorate. I think the most likely scenario is probably I'll go for a master's, and then if I fall in love with what I'm doing, I might stay through to a PhD, but we'll see. I mean, I would frankly like to get back in the workforce. I really working at MakerBot this summer was phenomenal. I would go back there in an instant. Next summer, my intention is, for the first time ever, I think I'm going to not take a job and just like focus on my own stuff for a few months, which I've literally never done before.
Sure.
So
this is a common thing that you find with engineers too. A lot of the engineers don't end up going all the way through the path of academia because by their very nature, engineers like to be out there doing stuff. They like to be making things and building things.
And that's why I do so many side projects. Just you can only, you take courses and that's great, but you only get so much actual design experience in courses, which is kind of a shame.
Right.
So you have to supplement it.
I tell you what, though, the group of people that you're working with there at Cornell on your efficiency stuff, that sounds like you've got a really, really good zombie apocalypse team. I mean, like,
most definitely. We got some. I mean, so we it's a project team, and we interview for admission to the team because we want to see like what people we have a lot of different technical sub teams that people could be working on. Like we have bacterial digesters, and we have geothermal and solar panels and heating and HVAC and all that, sensor systems and all that stuff. So we interviewed people, and this was like the worst part of the semester. I interviewed, I think, somewhere around, it must have been about 170 people. Um,
Oh my
it,
gosh.
it was painful.
Sounds it.
But all the people we interviewed were just so awesome, and it's hard to pick people because yeah, it's like you have this zombie apocalypse dream team, all these people who have these all this awesome background knowledge and skills, and the people who don't have the skills, who are freshmen and stuff, they might not have the skills, but they're so insanely excited about getting involved in like a project like this,
Right.
and that's equally as important. Someone who you can just get to go to work right away and get awesome stuff done is
Right.
key.
Right. Now, are you thinking of continuing your master's, assuming you go for the master's at Cornell so you can keep with these groups?
I mean, I'm
Or is
considering
that just in the air right now?
it's up in the air. I mean, it's one of the options. I'm definitely going to apply for it.
Sure.
If I did it at Cornell, I would do the Master's of Engineering, which is a 1-year program, and then you get a master's. And I do some research and stuff too.
That's not bad.
It's a pretty good deal, and I mean, like I would get into it if you go to Cornell undergrad, like, and you have good grades and good recommendations, like you get into the program. It's not hard.
Sure.
So that's great, and I mean I would love it. I really like Cornell, and I already do cool stuff here, so it'd be great to stick around. But it'd also be nice to get a change of scenery. So I mean, I'm looking at places too.
Sure. Bring your brilliance to other places.
All right.
Yeah, see what kind of brilliance they can bestow on me.
We're running a little short here. I wanted to make sure we take just a minute to ask you this year's Maker Faire. What was the most impressive, most inspiring thing that you ran across?
Oh man, that is tough. There's so much. I don't know if I can pinpoint just one thing, but I can say one thing that really stuck out was Architect. Are you guys familiar with them?
Music group?
Yeah.
Yeah, the Tesla coils, I think.
Yeah,
right?
Tesla coils. I put a video of it up on my second YouTube channel. They played the Doctor Who theme song using Tesla coil, and oh my god, it was just awesome.
We talked about that a little bit last week. Yeah, that was yeah.
That was pretty phenomenal.
There's like efficient uses of energy, and then there's awesome uses of energy.
Right. Because they're I think they said there's like something like 4 million volts that they're using on this, which is completely absurd. And I saw another group there actually had like the capacitor generator for driving Tesla coil. Those things are ridiculous. One other thing I thought of at Maker Faire, I got to meet the Arduino team. And it's a picture with them up on my Facebook and on my Flickr and stuff, which is fun. And the most exciting part for me was like, oh yeah, I like your videos. And I was like, oh my god, they know who I am. And that was really exciting for me. So that was great. I mean, they're awesome guys.
You like my video? Why you no answer my email? Moving on.
They're awesome. They're awesome guys.
They seem like it, yeah.
They're pretty great.
Okay, so we always, at the end here, we let Addie grill the guest a little bit. So I'm going to let her do that.
All right. Well, one thing, are you still working on Arduino projects? I mean, I know you have a lot of
yeah, I mean, I'm busy. Yeah, so, for those 3 hours a night while I'm sleeping, sometimes I dream about tutorials. And no, I mean, I have, so like in the pipeline, I have a lot of tutorials, mostly user requests and things I want to get done. I can't give it top priority because if I do, I'll fail out of school.
Sure.
So I mean, I'm working on it. I haven't stopped with them anytime soon, but I also can't make any guarantees about when the next one is going to come out.
Oh, that's fine. That's fine.
But,
even at your own projects, not necessarily the tutorial for
for Arduino. Yeah, no, I mean, I've got my own stuff going on too, and I always have plans to do other things and things kicking around in my head. But
sure.
There's only so much time, and then even usually the most time-consuming part is not even actually doing the project, but like filming it and getting the documentation together, because I document the hell out of everything I do.
Right.
So, and that's
a lot of time.
It's very time-consuming.
Yeah.
So I do my best, and no one has to worry about my stuff going away anytime soon. But I can't say when the next thing will be out.
Right. No, that's fine. That's fine. I mean, you're a busy guy. Okay, so some of the questions. What are the 3 top tools that you would bring to your zombie apocalypse bunker?
Okay, this is tough. Let's think here. Okay, like do very generic things count, like duct tape and stuff, or
Well,
like what?
feel free. We can do power tools. We can do anything, really.
Like on your person, what 3 things do you know you're gonna grab when you go out the door to head towards your super efficient bunker?
Right.
Okay, let's see. Okay, definitely a 3D printer of some kind.
Okay.
That's critical.
Yep.
Definitely. All right, let's think here for a second.
So he's gonna mod his 3D printer so that it has backpack straps. Okay.
Yeah, and I mean, so this is key part. In addition to the 3D printer, this falls under one object, by the way. The replacement print heads for it of some kind, so I can like stick a Dremel in it and CNC stuff out in addition to doing additive stuff.
Nice.
Okay. So that in some fashion. And let's see what else. Some kind of water purification system.
Yep. Brilliant.
I
We might just have to give you the GPS coordinates to our bunker here.
Oh man.
Yeah, bring that all those carbon filters with you.
Yeah, some carbon filters, some iodine pills, all that kind of stuff. Okay, so that's important. And then what? So, but like, I need food. Like, does food count as something I have to bring? I mean,
sure. I mean, is there like a replicator somewhere that
Well, you got all that negative space on the inside of your 3D printer. You may be able to fit like a.
Can I pack it with like seeds?
Yeah, seeds and hydroponics
seeds
that
dirt
can like.
And hydroponics.
Yeah, there you go.
Brilliant.
Okay, so I'll use the filtered water. I'll 3D print some hydroponic vegetable pot things.
Nice.
And I'll pack the inside of that thing with seeds so I can plant some carrots or whatever.
Gotta keep that eyesight.
Oh wait, we can do one better here. Instead of the water filtration system, I'm gonna pack it with genetically modified seeds that can be used for nutrient film filtration of water. So I can 3D print hydroponics for the plants, grow the plants, use the plants to filter my water, and then I don't have to bring a water filter as a second item.
Nice.
And you said they were working on plant-based plastics for the MakerBot too.
Yeah, I mean, I have them. So I can, maybe I can turn. Oh, also I'll have to grow corn and extrude corn into PLA-based plastic, so that I can use it to make more pots and more plastics. This is very self-sustaining right here. I'm very excited. And then, okay, we're gonna need some kind of energy source to keep this thing running. So I'm gonna have no choice but to rob my nearest GE factory.
Yeah, that's fine.
And grab some solar panels. But if I can't do that, then I'm gonna need the materials necessary to make a turbine generator. So I'll need a bunch of copper wire, and I'll need some ferrous magnets.
Nice.
So that might be something. It'll either be that or solar panels, whichever one is more readily available. If I get solar panels or the other thing, I'll need an inverter too, though. So there's that, and then the third thing. What would the third thing be? Am I alone or do I have friends?
Well, you're gonna be coming to a bunker, so everybody's gonna be bringing stuff.
So
anyway.
Everyone's bringing stuff. Okay.
Yeah, we got saws, we got soldering irons, we got. I'm sure with a bunch of guys, you got duct tape somewhere.
Okay.
So we got.
So did anyone say like laptop?
Well, you got to remember which crowd we're talking about. Most of the people that we talk to can build a laptop from silicon. So.
I didn't know. Well, are they also planning on bringing a silicon fab lab into the bunker with them?
We haven't interviewed Jerry yet.
I'm sure Jerry will, make that work. me, her, and Chris Gamble can 3D print some transistors, and then
God, don't tell Dave.
Dave will have a hissy fit. But oh man. So okay, so I've got one more thing. Let's see. This is tough.
A good book.
Toilet paper.
Ooh, that's.
Oh my.
I mean, that's important. No, you know what? Maybe medicine.
Yeah.
Medicine.
Sure.
Yeah.
Just like fill a box with all the medicine I can get. Everything from Tylenol to Gas X to antibiotics and. Well, I mean, come on. You don't want people farting and making the whole bunker smell. That's not cool.
Well, if there's gonna be gas passed, you can be using that methane to
do something.
Yeah, we can use that as another source of energy generation. We can use that to we can set up an anaerobic digester and get some heating going on using methane gas.
Yeah, we had a whole episode with John S.A.Z. where he kept bringing up poop.
Hey, you can do a lot with poop.
So
in a post-apocalyptic world, you got to take advantage of everything you got.
Yeah, I guess so. Coming in, going out. Yep.
Okay, so I think that's all my things, right?
That is probably the most well thought out 3 things that we've had thus far.
Jeremy's civilization in a box, unpatented, pending. Because this is all open hardware, folks.
This will be released Creative Commons, right? Jeremy's Build a Civilization in 5 minutes kit.
It's gonna have a big open hardware logo on the backpack.
Yeah. I actually have an open hardware logo on my backpack now.
There you go.
One of the giveaways at the Open Hardware Summit was an open hardware patch that you iron on, so I ironed it onto my backpack.
Awesome.
Very nice. Gosh.
All right, folks. If you want to check out the stuff that Jeremy does, you can Google him. He is very findable.
Yep.
It's
Jeremy Blum.
He's got a website.
BLUM.
He's got his YouTube channel, which has a ton of awesome tutorials and cooking shows as well. But never mind.
There's only 2 cooking shows.
And that's youtube.com/SciGuy14, SCI Guy 14, and that's also his Twitter.
Yeah,
name.
He's always on Twitter, going back and forth, chatting with folks, being generally useful to the community in general.
Yeah.
I mooch too. It's not all it's give and take.
So I think it's pretty easy to find Jeremy's stuff. So that pretty much wraps it up for today. Thank you, Jeremy, for joining us on this week.
Thank you very much.
Totally.
We'll probably ping you again later in the semester when you're not so busy. See if we can get you on. We'd like to do a combo with you and another interesting person, which has not been announced yet. But
okay.
The viewers will get a kick out of that one, as I'm sure they will have enjoyed this one. That one's going to be even better.
Yep.
Great.
You got anything else, Eddie?
I think...
Is that it? All right. Well, that was a really fun hour. I enjoyed myself. Thanks for joining us. Thanks for listening to ZombieTech. You can automatically get this show delivered to your phone, your iTunes, whatever. There's a link on the side. It's feeds.tymkrs.com. And we'll
Till next
see
time.
you guys next week.
Bye.
See ya.
Bye.